Core 2, June 2013, question 3. This is a nice binomial expansion question. The thing to note here is that everything starts with the word hence, so you're going to need to use your working to get full marks. And the first part is a straightforward binomial expansion. It does say or otherwise, so you could just multiply out the brackets if you'd forgotten how to use the binomial expansion, but binomial is the fastest way. So what we're going to do with the binomial, it's in the formula book, okay, is start off with a, in this case that's 2, so 2 cubed, because n is 3. Then the next term is going to be 3c1, that's how you put it into your calculator, times 2 squared, so the power goes down on the a, and then we introduce the b, which in this case is a y, so times y to the power of 1, plus 3c2 times 2 now to the power of 1 times y squared. And now we're going to be at the end of the formula, because I would next write 3c3, which is 1, so we're at the end. 2 to the power of 0 is 1, so plus y cubed. Then I just simplify all the coefficients, all the number parts. 2 cubed is 8. 3c1 is 3, you could put that in your calculator, times 2 squared, so 3 times 4 is 12y. 3c2 is also 3, 3 times 2 is 6, y squared, plus y cubed. So that's part 1. Now part 2, as we said, has a hence. So without expanding it all again, we're going to show that this can be expressed in that form. How do we do this? Well, we notice that 2 plus x to the minus 2 cubed. The only difference here is it's exactly the same as the first part, but instead of y, we've got x to the minus 2. This means that everywhere in our expanded version here, we can replace y with x to the minus 2, and that will be the answer. So that's 8 plus 12. Here we've got a y, so that's x to the minus 2. Now we've got a y squared. Now y is x to the minus 2, so that's all squared, plus x to the minus 2 all cubed. So that's going to give me 8 plus 12 x to the minus 2 plus 6x. Using our rules of indices, that's a minus 4 plus x, negative 2 times 3 to the minus 6. We're then going to do the same. Now we've got 2 minus x to minus 2 cubed. Now all that's going to happen here is it would be exactly the same, except this time we've got a negative in front of the x to the minus 2. So if we replaced using our answer to part 1, we would now have 12 times negative x to the minus 2 plus 6 negative x to the minus 2 squared plus negative x to the minus 2 cubed. You could simplify that, you could leave it unsimplified to see what's the same. If you simplify that, we're going to get 8. Now here, we've now got negative 12x to the negative 2. Now when you square a negative, it becomes positive, so this stays as plus 6, x to the negative 4. And then here we've got a negative x cubed, so that's going to become a negative, so negative x to the negative 6. Right, the question then asks us to add these two terms together and show that it can be expressed in this form, p plus qx to the minus 4, where p and q should be integers. So that's what we're looking for. So now I'm going to take my two expressions and add them together. So 2 plus x to the negative 2 cubed plus 2 minus x to the negative 2 cubed. It's going to be 8 plus 12x negative 2 plus 6x negative 4 plus x negative 6. So that was my first expression. From here, plus the second term expanded, so plus 8 negative 12x to the negative 2 plus 6x to the negative 4, take away x to the negative 6. Now in writing it this way, you can see that when we gather like terms, I've got 8 and 8, so that's going to give me 16. Now when I come to the x to the negative 2, I've got plus 12 minus 12, so they're going to cancel out. Then I've got 6x to the negative 4 plus 6x to the negative 4, so that's plus 12x to the negative 4. And then I've got x to the negative 6 minus x to the negative 6, so they're going to cancel out. So this is my final answer in the form that was requested.